In this video, we're going to look at applications of quadratics, and we're going to look at a situation where we examine revenue of an apartment complex. Let's start by just reading the problem, and then we're going to kind of break it into parts. It says the manager of a 90-unit complex knows from experience that at a rent of $800, all the units will be rented out, all 90 of them. On average, an additional unit will remain vacant for each increase in price of $30. So, like for example, if this went up to $830, one of those units would probably go unrented. Once again, as you drive up price, the demand is going to go down. I think that kind of makes sense. It says furthermore, he must keep at least 30 units rented due to their financial considerations. If the revenue from the complex is currently 66820, how many apartments are rented? So here's what we got to think about. In order to set up our equation, I want us to think about this a certain way. I want us to think, okay, if I did the number of apartments rented and I multiplied that by the cost per apartment, that equation would give me their total revenue. Okay? And so this is kind of the bones of our equation. This is the template that our equation is going to take. If we can find out how many people are paying and how much each one of them is paying, and I multiply those, that's going to give us our revenue. And so what we're going to do then is, with most of these, we need a variable. Okay? And what we're trying to figure out is we're trying to find out, it's actually kind of vague here because it says we're trying to find how many apartments are rented, but our first sub-goal in this situation is going to be to find out the number of $30 increases. In other words, was the price $800? Was it $830? Was it $860? Was it $890? Okay? And so let's let X equal the number of $30 price increases. Now, let's start with our cost per apartment. I'm going to come back over here. It says normally the cost is $800, but if we increased the price, if we had one $30 price increase, the price would go up $30. But if we had two price increases, it would go up 30 times 2. If we had three price increases, it would go up 30 times 3. So what we have is we're going to write an expression for the cost of each apartment as 800 plus 30x, where x is the number of $30 price increases. Now let's come over to our apartments rented. We know that normally there's 90 units, but they tell us up here, they say that on average, one unit will remain vacant for each $30 increase in rent. That means if there's currently 90 units rented, but we hiked the price by $30, we would lose one apartment. If we hiked it by $60, we'd lose 2. So it'd be negative 1 times 2. Basically, this is our expression that reveals the number of apartments rented as a function of price increases. And this is our expression that represents the cost as a function of the number of price increases. If I multiplied this times this, we're going to see in a minute it's a quadratic, but what we're trying to do is we're trying to solve this equation and find out, okay, well, how many are rented if we made this much money? And so what we're going to do is I'm just going to distribute, and I'm going to kind of do that real quick. 90 times 800 is going to give us 7,200. Then 90 times 30x is going to give us 270x minus 800x minus 30x squared, and this is going to be equal to 66820. Now let's do just a little bit of simplification. I still have my 7,200. I'm going to combine some like terms right there, and that's going to give me negative 530x. And then I still have my negative 30x squared equals 66820. And then just to rearrange a little bit further, I'm going to write my quadratic term first, my linear term second, and then let's just bring everything over to one side of the equation. Oh, I think I left off a 0. I apologize if that was confusing somebody. That should be 72,000. So if I subtract 66820 from each side, that's going to give us our constant, which is 5180, and that equals 0. So now we've got a quadratic that we can solve. I'm going to skip the actual solving of it. I would suggest going to quadratic formula for this problem. But what we're going to be left with is two solutions from our quadratic formula. We'll be left with x equals 7 and x equals negative 24.6. Repeating, okay? Now, let's think, these are both valid solutions to this just as an equation, but when we think about the context of the problem, we're going to find that this is an extraneous solution, okay? The reason that's extraneous is that would mean that our number of $30 price increases is negative 24.6. Well, if you multiplied 24 times 30, I'm not even sure what that would be. What would that be? That would mean we discounted our rent by almost $720, but we would need so many people for that to equal 66820. Since we know we have a maximum of 90 apartments, this basically is not feasible. We're going to throw that out for a number of reasons. I know my explanation on why we're throwing that out wasn't super smooth, but we're going to throw that one out. So in order to get this much revenue, we had 7 price increases. Let's think about what that means in terms of our problem. So yes, x equals 7 is the solution, but how many apartments were rented? Well, we know that for each one of those increases, we had, actually I should say this, we had this many apartments rented. So if x was 7, then 90 minus 7 means we had 83 apartments rented. And it didn't really ask for it, but just out of curiosity, it said, let's look at the cost per unit. That would be 800 plus 30 times 7. In other words, 800 plus 210. That means we were charging for apartments $1,110. Oops. Did I say 110? So that would be the price. This would be the number of apartments.